All right, to review from yesterday, if we're looking for points of discontinuity, you want to first factor. All right, you're only going to look at the denominator and set each piece of the denominator equal to 0. All right. When you solve that, you check and see if there's a matching factor. Now, if you look at the x plus 2 has a matching factor on top and bottom, that means that it makes a whole and it's what we call removable. And so the whole is indicated as an open circle on the graph. The x minus 2 does not have a matching factor, and so it's going to make a vertical asymptote. An asymptote is indicated by a dotted line, and it's a line that your graph gets close to but doesn't touch. And so you can see that it gets really close, but it never actually reaches that line. Today we're going to focus on horizontal asymptotes, and when we get back to class, we're going to bring it all together and do some graphing. All right, so the steps for graphing starts with factoring so that you can find your vertical asymptotes and holes. That's what we did yesterday. And today you're going to find the horizontal asymptote. If it exists, there's only one, and it uses a certain set of rules. These rules will be given to you. You do not have to memorize them, but you do need to know how to use them. And then you're going to need to use some technology to help you graph, or you could just plot a bunch of points, which nobody wants to do. So I have my graphing calculator over here, and we'll be using this today. So to review, vertical asymptotes happen at non-removable discontinuities. All right, Gandalf, you shall not pass. In this case, we would have one at x equals -7, right? Because if you solve the denominator, this one we would have one at x equals 1 and another one at x equals -3. So you have to solve each piece of the denominator. This one we're going to have a whole at x equals 2 and a vertical asymptote at x equals -3. All right, so these are both vertical asymptotes. I'll label that. They're both. So you can have 1, 2, you could even have no vertical asymptotes. So today, these are the rules. I would write them down so you can use them when you're solving the homework. And you're looking at m and n being the highest exponents. All right, so I'm going to highlight that for you. M is the highest exponent of the numerator, and n is the highest exponent of the denominator. So you're looking at the numerator and the denominator first. All right, in this case, since m equals 2 and n equals 2, then we would use the middle rule. The horizontal asymptote is y equals, the coefficients are a and b. A and b are the numbers out front, so that would be 6/2, which is 3. I'll circle that or highlight that for you. A and b are the coefficients out front. All right, so we're just going to be looking at the exponents and then deciding which rule to use. A and b are the numbers out front. M and n are the exponents, so kind of keep those separated. So what is the horizontal asymptote? We first look at m and n. In this case, m equals 1 and n equals 2. So m is less than n. And we can kind of think, okay, well, what does that mean? M is less than n. The horizontal asymptote is y equals 0. So we're going to look for m and n again. M is the highest exponent, 3, and n is the highest exponent in the denominator, that's 3. So m equals n, and we look at our rules. If m equals n, the horizontal asymptote, we have to look at the coefficients. The coefficients in this case are 2 and 1. If there's nothing there, use a 1. So our horizontal asymptote is going to be at y equals 2/1, which is 2. All right. In this case, m equals 2 and n equals 1. So m is greater than n. Let's check our rules. If m is greater than n, there is no horizontal asymptote. Which is just fine. All right. In this case, you could use your shifts from the transformations, right? Funny joke. You could say, "Holy shift! Look at the asymptote on that mother function." Or you can use the rules, right? If it's a shift, it's not going up or down at all, so we kind of already know that the horizontal asymptote is at 0, and the +1 in the denominator indicates that it would move to the left 1, and so it would be a vertical asymptote at -1, horizontal asymptote at 0. But if we look at, if there's nothing in the numerator, m equals 0 because there's no variable, and n in this case equals 1, so m is less than n. If we check our rules, that means there's a horizontal asymptote at y equals 0, which we kind of already knew. So sketching the graphs, you want to walk through these steps: factor, find asymptotes and holes, plot the asymptotes, and then use technology to help you graph. All right, we're going to try to pull the graphing together, I think, on when we get back tomorrow. If we have school or whatever the next day. And so your focus today should be on the horizontal asymptotes. Looking at this, if we're checking for horizontal asymptote, we have m is greater than n because m is 2 and n is 1. So the horizontal asymptote, if we use our rules, m is greater than n, no horizontal asymptote. If we look for our vertical asymptotes, we need to factor first. And so if we factor the top, we get x minus 4 and x plus 1. And the denominator is that x minus 2. All right, so we know that there is a vertical asymptote at x equals 2. And we know that because there is no matching factor on top and bottom. Oh, there's my asymptote line. So I'm going to make an asymptote line at x equals 2, vertical asymptote. There is no horizontal asymptote. And so then I want to see how the graph looks. Is it, where is it on here? And to do that, we need to go into our y equals. I recommend that you use parentheses. Parentheses on the top and parentheses on the bottom. I would just type it in as your very first thing that's given to you in the problem. That way, if you factored it wrong, you can kind of double check your work and see, like, is there actually an asymptote at 2? Well, there it is. So then you can sketch that in over here on your graph. It doesn't have to be 100%, but it should look like, oh, okay, well, good enough. It should look like the graph on your calculator, and you can see there is a vertical asymptote. There's no horizontal asymptote, right? So we're correct. Yay. It's a great way to check your work. In this case, if you look at m and n, the exponents, they're both 2. So our horizontal asymptote is at the line y equals 3 over 1, or 3. So I can draw in an asymptote line, horizontal at 3. Right now I want to check for any vertical asymptotes, and to do that I need to factor. All right, so the numerator does not factor. The denominator does. We go x plus 2, x minus 2. And so then we have 2 vertical asymptotes. We have a vertical asymptote at -2 and 2. Because there's no matching factor on top and bottom. All right, so I'm going to make lines at both 2 and -2. This one should be pretty fun. All right, if we type it into our y equals, again, I'm going to use parentheses just to be very careful. And I also want to use the very first problem that was given, just in case I factored wrong. That way I can check my work and see if the graph matches what I think it should match. And there it is. Look at that, pretty cool. So you can sketch that in. To here. Okay. Good enough. Good enough. That looks great. Good job, self. Full credit on the test. All right. So I'll just do a couple more examples of this, but remember your focus is on the horizontal asymptotes today. In this case, our m is 1 and n is 2, so m is less than n. I forget my rule. I can always go back and look because they're going to be given to me on the test. M is less than n, y equals 0. So I have a horizontal asymptote at y equals 0. You are going to want to sketch that in, even if, oh, why did that change? Even if it's at 0, just to indicate that you know that there is an asymptote at 0. Maybe I'll do it in a different color. There. Next step for vertical asymptotes, I'm going to need to factor to see if there's any matching factors on top or bottom. And there's not, so we have a vertical asymptote at x equals -2. So I'm going to draw that in. And then we need to figure out what our graph looks like. And in here, I'm going to use parentheses and type it in the initial form before I started working with the problem. Oh, cool. So there it is. You can't always guess what it's going to be because it might look a little bit different. That's fun. So they're both facing down in this case. Yeah, full credit on the test because you know what? You can tell the shape, you know, you can tell somebody checked the shape there of the work. All right, last one. Let's look for our horizontal asymptotes first. And in this case, m is greater than n because the top exponent is 2, the bottom exponent is 1. So we have a horizontal asymptote if m is greater than n. Oh, there's no horizontal asymptote. If we factor this to find our vertical asymptotes, x plus 4, x minus 4 in the top, and x minus 4 in the denominator. So actually, we have only a whole at x equals 4, no vertical asymptotes, because there is a matching factor on top and bottom, and then that's the only thing in the denominator. So since that's the only thing in the denominator, there is no more vertical asymptotes, just the whole. So we have to draw in the whole though. Let's see what the graph looks like, and then we can draw in the whole after we see what the graph looks like. X squared minus 16 divided by x minus 4. Yeah, it looks like a straight line. So what I would do is I would make that straight line. It's linear. Oh yeah, because it's x plus 4. That's fun. Pretend to draw it. Okay. Whole at 4. 2, 3, 4. Whole at 4. And then continue on. Okay. There you go. So with your pencil, you could just erase at that point and make the hole, and then continue the line on either side. That's how you draw in a hole. All right, happy solving.